SAT test 10, question number 18 on the non-calculator section. We have Juan purchased an antique that had a value of 200 at the time of purchase. So in the beginning, whatever Juan purchased, the object Juan purchased, had a value of $200. Each year, the value of the antique is estimated to increase 10% over its value of the previous year. So this is very important here. When the increase is not 10% each year, but 10% over its value of the previous year, we have an exponential relationship, right? That means the increase is going to be different every year. It's going to be 10% of the previous. So it will change. The estimated value of the antique in dollars 2 years after the purchase can be represented by the expression 200A, where A is a constant. What is the value of A? So basically here, we need to know how to build an exponential expression from the word problem, and then we'll solve an equation. When we have an exponential expression, exponential function, here is the form of it. F of x will equal A times B to the x exponent. That's an exponential function. It's very important to know how to read and how to determine what's the meaning of each of these variables. A is always the starting value. B is the growth factor. And x is the independent variable, right? In exponential function questions, y is the output. F of x is y, right? The output. Usually x will be time, most likely, and we'll take it from there. So now we know that our value is going to be the ending value of the antique after 2 years. So how much is that? Well, they say it's 200A. A is the starting value. They said it's 200. This is information I'm getting from the text. So the output is how much that antique will be valued at after the ending of the 2 years. I get that information from here. And that's why I replace f of x with it. The starting amount is 200 at the beginning of the purchase. The growth factor will be how much that does the value increase. However, remember, it is not only 10%. We get it by 1 plus 10%. That's how we get the growth factor. And then x is the amount of years. So now if I simplify that, I have 200A would equal 200 times 1.1 squared. Well, how much is A? Obviously, the 200s will cancel out, and A becomes 1.1 squared. Now, remember, this is non-calculator section, so it's going to be a little challenging, but it's very easy to determine. 1.1 is 11. Like in term 11 divided by 10, right? So 11 times 11 is 121. When we have a decimal, we'll have two decimal places, so A becomes 1.21, and that's going to be your solution. That is if you have an understanding of exponential functions, right? And I'm going to go over two things. How do we get the growth factor? And also, what's an alternative way of solving that question if we don't think about the exponential problems? So the growth factor B, if it's a number more than 1, right? If it's a value more than 1, we have an exponential increase. And if it's a number less than 1, we have an exponential decrease. Okay. Or exponential growth and exponential decay. Now, how do we get B? B always equals 1 plus the rate of change if it's an exponential growth, or 1 minus the percentage change, the rate of change if it's an exponential decay. In our case, we know it's an exponential growth because the value increases. So I'm going to use the plus. So b is going to be 1 plus the rate is 10%. I'm going to get it converted into a decimal. So b is going to be 1.1. That's how we got that for our problem. And now quickly I'm going to cover how could you solve this problem in another way if you don't think of exponential functions. So they're saying in the beginning the antique is valued at 200. After 1 year, it's going to increase 10%, right? So it's going to be 200 plus 10%, which is 0.10 of 200. This is going to be 200 plus 20, 220. After another year, it's going to increase another 10%, but based on the 220. So it's going to be 220 plus 10% of 220, which is 220 plus 22, 242, which means in 2 years, following the 10% increase every year based on the previous one, my antique will be valued at $242. Okay. Now, how do I find A? Once I know that 242 also has to equal 200A because that's what they're saying. 200A is the value after 2 years, but I just found it to be 242. And dividing by 200 both sides of that equation, I get A to be 1.21. The difficult thing about this part and this type of solving that particular problem is that that's a non-calculator section, so you will have to perform these calculations manually and precisely. But there is a way out if you don't. That's the way out if you don't think of exponential functions.